instruments because they're somewhat old. This limits the amount of current that we can get from them and makes it harder to drive motors, the computers, and all manner of other things. Okay, so Team Petazoo Aperture Science subsidiary is having computer problems, but Team 2, whose team name is Hey, I think we're Team 2, is ready to go. All right, so what do you think is one of the more interesting features on your box? Are there any other components that you're particularly proud of?
So we have a 2 degrees of freedom camera that's mounted on different servos for picking off, and it helps us get better range estimates and heading estimates without doing a lot of input processing.
So you do those sorts of adjustments in, sorry, we're blocking the projector here. You're doing those sorts of adjustments then in real time. So how great is your field of view?
So I think the field of view is like 45 degrees or something that's pretty fast. So we use the camera to help us around it.
Okay. And it looks like you're on.
Yeah.
So I'm guessing that you're in a basic exploratory stage. It looks like you're trying to find a wall. Is that right?
I think so. I think it's a ball. So it dies to it, and then it looks at it. Oh, I guess it missed it.
So if it sees a ball, then the camera seems to move.
Yeah, the camera will pan around and check if it's caught a ball.
Okay, so there's kind of the first indication, and then after that, confirmation.
Yeah, confirmation, and then it tends to dive to the ball. So I think it's turning on it. And then it stops there, and then it checks again. But I think it's driving people close to it.
It looks like you have a bit of a blind spot right there in front of your gate.
I don't know, it's driving people too fast. So I think it's on goal.
Maybe this one's close enough?
So I should open the arm.
So are you keeping track of the number of balls?
So it assumes that every time you go through a ball that it tests it. And then maybe that's something not as good as sometimes
I don't know if it's quiet enough for the audience to hear, but there's just a marvelous little click, click, click noise that the servo makes whenever it goes. It's eerie.
I guess it needs to see that ball over there, but I'm not sure what it's going to do.
So when you lift up the gate,
You lift it up in the last second. Try to get it.
is there a particular reason for that strategy?
So we're having trouble with it. And then it knocks the ball over. So I think this sees the goal, so it's picking it up. And then it kind of hands around to help align itself with the goal. And then, it is goal scoring. So then we can straight back and forth, so we have a wiggle routine.
So that's one in the goal and one on the porch, it looks like.
Yeah, so hopefully it ignores the ball closest to the goal. I'm not sure, it kind of rotates with it again.
So I just think as a general overview, a lot of teams are using something called, what we call an FSM, as a finite state machine. And the basic idea is that you have various sorts of actions that you can perform, and then from those actions, you can go to a different one. So you might have an explore state, where you're going around and just exploring the field. And then there might be something in the environment that triggers you to go to another state, like the goal scoring routine. So are you guys using FSM?
We use an FSM, and then switches between ball following, goal scoring, and ball following.
So it's just those primary three and nothing else?
Oh, and a stuck routine. So I think it's
So I don't notice any bump sensors. How are you doing your stuck machine?
There are encoders on the wheel, and then it figures out if the wheels are not moving. And so in certain stages, it can get stuck, like while it's driving around and all.
Right. Again, just a bit of background knowledge. Encoders on the wheel means that there are little tick marks on the inside of the wheel that the robot is able to read. So it's able to say, okay, I have 8 ticks for every revolution, so you're able to see how far you go. You can also tell whether or not you're stalled, I understand Donald to say, by seeing whether or not you're trying to drive that motor and whether or not the tick marks are changing at all.
So I guess it got stuck a little prematurely there, and that's where it's going to the bottom.
So a minute left. There's a big easy button on the side of your computer.
That was for our emergency kill button, which came in handy while we were debugging. There's no real way to go.
Well, it's good, when they become self-aware, you want a button. So, that was actually very nice. So did it see the ball and then realign, or?
It sees it now, and then I get the story for it. So then it adapts it.
There you go. Okay, so timer is just completed. We'll see if it stops, and it has.